Okay, welcome to lecture 10 of CST 3205. In this lecture I'm going to cover RESTful web services. So I'm going to start with a fairly detailed explanation of what a RESTful web service is and how you design RESTful APIs. Then I'm going to go into a couple of topics that I just didn't have time to cover last year as part of the two lectures I gave on Node, which are connection pools and callbacks. So both of these are well worth understanding in a bit more detail if you're going to build, some kind of website based on a database using Node. And then I'm going to explain the sort of design of the REST API that I'm going to use as an example. And then I'm going to explain how you can implement that design in Node.js. So obviously this is just an example, but I thought I'd give you an example to get you started with this in your projects. Right, so REST API. So it's sometimes called RESTful. Sounds kind of, relaxing, I suppose. And what it is an architectural style that defines a set of constraints for creating web services. So it's not some kind of super rigid prescribed standard, when these are engineering standard kind of things. It's more like a set of best practices or guidelines that most people follow when they're building RESTful web services because they know that this works. Yeah, it's a good way of building web services. So it's a good way to expose data internally if you've got some kind of distributed application running on your corporate network, whatever, or public on the internet. I mean, a lot of companies, as I'll say, use RESTful web services to expose bits of their data so that other people can access and use them. So here's some examples. So we've got, Facebook Graph, Twitter, Amazon S3, Google Maps, Nest, Tesco, and so on and so forth. So RESTful web service is a very popular way of using HTTP, some conventions, and then you can just expose your data and then people can use it. And then you can also expose your own data to yourself, so to speak, so that you can use it either internally or as part of a website, as I'll explain next week. So here are some of the advantages. So one advantage is the single API, i.e. the RESTful API, supports lots of different methods of interaction. So these days, if you're building a sort of big, product, whatever, web service, web-based product, shall we say, internet-based product, then there are going to be lots of different ways in which people are going to interact with your product, right? Maybe you're going to build an app so that people can, use, so take the weather, right? You might have a weather app that lets people access the weather. You might also have a website that lets people view the weather in their browser. And you might also have, make your weather data available to third parties as well. Maybe people could pay to use your API, and then they could include your weather data in their websites. So ideally, you're going to build a single API, some kind of internet-based API, and then these different methods of accessing it are just going to be front ends to the same API. You don't want to build an entirely sort of enclosed app, based on one sort of database, and then build a website based on another kind of database, and a third-party access based on another third-party database, another database. That's going to be a complete mess, right? You want to just build a single backend that can be accessed by multiple front ends, and REST APIs are a very good way of building that single backend. It's a widely used set of protocols and conventions, so that's got two sort of wins, right? One win is that other people understand your REST API really easily. They don't have to do lots of work to read all your documentation because it's just a standard REST API of some kind. It also suggests if lots and lots of people are using it, obviously it's probably quite a good thing, right? And obviously if lots of people are using it and you learn how to build your own REST APIs, then, that'll help you with your employability as well. So REST APIs, allegedly, but probably have these other features like scalability, simplicity. They are simple, they are beautiful. It's a nice way of designing a web service. I like it. Modifiability, so we'll come to this like layered constraint, which supports the modifiability. And reliability. I mean, reliability obviously depends on your implementation, but they're kind of very easy to test as well, right? You can easily write a bit of code that pings your web service and make sure it's replying with the correct kinds of responses. And because it's so clearly defined, because it's so simple and clear, it's easier to make it reliable than some kind of super complex thing based upon, heaven knows what. As usual, I had a flick at RESTful jobs. So, there's loads of them, right? We've got 32 pages there. You know, a lot of them, you know, Spring, Java Enterprise Edition, SQL. I think quite a lot of them are .NET, but that's okay. If you can learn to build one in Java or build one in Node, you can build one in .NET. But anyway, there's plenty of jobs out there, plenty of companies out there that are using RESTful web services and include this as a keyword in their job advertisements. So what is REST? So it's REST stands for Representational State Transfer. So the key, so it's an interaction between a client and server, as I'll explain when we come to the sort of more formal definitions. So we've got a client communicating with a server. The client does not sort of directly access the database on the server. That'd be, you know, kind of risky, among other things. So it doesn't have full access to the resource, and the resource might not be a database at all, right? It could be just someone sitting in a console typing out the responses. It doesn't matter how the data is generated, and that's the beauty and the whole point of the RESTful thing, yeah? So client doesn't have full access to the resource. Instead, the client accesses different representations of the resource on demand. So it accesses representations, not the full resource itself. And that representation thing is what brings a lot of these advantages. And each representation captures the current or intended state of the resource. So I'm accessing the state of the resource, a representation of the state of the resource, okay? And because we have got this client-server interaction, this representation of the state is transferred from the server to the client. So it's kind of easy. We're just accessing representations of a state that are transferred to the client, and that's what this REST thing stands for. And so typically the representations consist of data, you know, a particular representation of the resource, you know, as a form of data. You can also have some metadata describing the data. That's sort of built into the thing as well. So a very simple example, say we've got a resource, a person, you know, myself, for example. I might have a bunch of services or contact information, you know, and one of these services might be my contact information, and in this case this be implemented. So you don't have to use HTTP with RESTful. You could use any old protocol you like. It's a sort of general set of guiding principles for a web service, right? But typically, because it's a web service and because HTTP is great, you're going to use HTTP methods to access the resources. Yes, in this case we're going to, you know, get. So we might send a get to this particular service contact information. We want to get the contact information, and then we'll get a particular representation of the contact information. We might get the name, the address, the phone number of this person, yeah, this resource. And this might be formatted in JSON or XML or whatever, right? RESTful doesn't specify that you have to use JSON, doesn't specify that you have to use HTTP. It's just a sort of general way of, you know, a general architectural style, should we say, yeah? And obviously, contact information, in this case, is name, address, phone number. That's one representation of the data of this resource. This resource's contact information. Obviously, it could also include the email. It could also include, you know, contact information, email, Facebook, whatever. You know, there could be a bunch of other data in the database that isn't included in this particular representation. So these are the REST constraints. These are what constrain a RESTful web service, and any RESTful web service should conform to the first 6 of these. Okay, we're sort of going to half ignore this kind of code and demand one, which is a little bit weird. And all this was about this guy Fielding, I think it was. So he had his PhD thesis, and like one chapter of that, which I'll give you a link to in the resources, sort of sets out this idea of RESTful, of these REST constraints. So that's where all this is kind of coming from. So the constraints are, it's a client-server interaction. We've got 2 separate systems interacting, and they're interacting through this interface, this uniform interface, which is what we define when we create the RESTful web service, is this link between the 2. So they've got the interface linking a client and server. It's stateless. Again, this is sort of, you know, linking up with all this HTTP stuff. So the server does not track the client request. The client contacts the server, you know, either send some data to the server, get some data back, or a bit of both, and then that's the end of the interaction. You contact, you know, send the request, get back the response, and then that's it. There's no sort of cross sort of request tracking, or at least it's not any cross request tracking is not built into the RESTful protocol, RESTful thing itself. Yeah. So you can cache stuff. This is where it becomes scalable, right? Because we can cache data at multiple levels. And the data is explicitly or implicitly labeled as cacheable and non-cacheable. This shouldn't really affect the client so much, except the client can sort of cache the data, I suppose. So we might cache the response of a GET request for a few seconds or something like that. Again, HTTP has all that, or, you know, browser supports all that. But, you know, within the RESTful thing, you can label, explicitly or implicitly label stuff as cacheable and non-cacheable. So post or put, I think it's not cacheable, but obviously get probably is. It's a uniform interface. So the whole thing about RESTful is to have a nice, clean interface between the client and server, and that's one of the things I really like about it. It's a layered system, yeah? So the client and the server are interacting at a single particular layer. So the server doesn't know what, you know, necessarily what browser the client's using, you know, whether they're running Linux, you know, whether they're wearing a hat, right? None of that matters here, yeah? And equally, the client just is sending, you know, communicating, you know, probably with HTTP, and it doesn't know, you know, what database the server's using, doesn't know what, you know, whether it's using PHP or Node or whatever, it doesn't care, right? And it doesn't also care if there's like loads of cache layers hidden in the server somewhere to kind of speed up the whole thing. So, so both the client and the server are interacting within a single layer, and there's likely to be lots of layers above and, you know, below all that, yeah? Then we got this funny code on demand one, which is Fielding's thing probably. So it's kind of true. We can extend client functionality by extending scripts, you know, and then the browser can download JavaScript or whatever. But this is actually an optional constraint. So I'd actually focus, when you're thinking about RESTful, not about code on demand, you know, whether your RESTful web service supports code on demand or not. Who cares, right? Let's just, you know, focus on these 6 constraints, which are good, solid constraints for any RESTful web service. So just to say a tiny bit more about each of these, some of these, the more important constraints, or the less obvious ones, shall I say. So this is the stateless interaction constraint. So each request contains all the information necessary for the server to understand it, independently of any request that precede it. You're not going to send the server little chunks of data, and when, you know, it's got all the data, it will then respond back. The idea of RESTful is that the request contains everything that's needed, and then the server can respond to it. And if 5 minutes later, you know, the client wants the same stuff, it has to send off the same request. The server's not tracking previous requests that the client has made. That's not built into this, the idea of a RESTful interface. Of course, it could track previous requests, but, you know, that's separate from the RESTful web service, yeah? So what happens is the client sends HTTP request. If we're using HTTP, which we kind of slip into sort of using just HTTP anyway, but with you know, I'll mention that a little later. It receives a response from the server, and that is it as far as the RESTful API is concerned. So think in these terms, okay? Don't think in terms of tracking or cookies or any of that kind of stuff. That's all separate from the RESTful web service, and probably better use that for browsers more than probably use it for a REST API. So you can manage the state by the client. So the client can say, well, you know, I've requested this, and then I need to request that. So the client could do like a sequence of calls to the RESTful web service and manage the state in between these calls. And this, obviously, maybe the server could hold, you know, stuff in a database, but it's not part of the REST API. The REST API is simple, scalable, all the rest of it, because it doesn't mess about trying to keep track of, you know, multiple, you know, interactions with the client. The server doesn't care who the client is, unless you've got some kind of authentication going on. It basically just deals with the client's requests as they come. That's the sort of intuition that should be guiding you when you're building this stuff, yeah. Then we've got the uniform interface constraint. So you've got to obviously clearly define the interface between the client and the server. And as I've been sort of mentioning sort of several times already, the REST APIs are usually implemented with HTTP, because HTTP is a sort of beautiful protocol in itself. And then we can combine that with this sort of RESTful stuff and actually have a very nice way of accessing and manipulating data. So we're going to use the HTTP verbs, you know, get, or methods. So get, put, post, and delete. I mean, there's lots of other ones, but these are the main ones that we need to think about when designing our RESTful web service. Then we're going to have URLs, or you're going to use URLs rather than URIs. I'll explain the difference in a second, which are used to name resources. And then we got the response. HTTP already has a bunch of, you know, very useful like status codes, right, which we can just use straight out of the box for our RESTful web service. And, you know, these days we're using JSON formatted data in the body, which again comes from this whole kind of web stuff, yeah. So what we're doing is we're accessing a representation of a state of a resource, yeah. Yeah, that's right. And so obviously you need to be a little bit clear about what we mean by resources. So anything that can be named can be a resource. These are a rough sort of guideline here. And we identify resources by universal resource identifiers. So when you read sort of tutorials or whatever on RESTful web services, they often talk about URIs, which is a little bit confusing because our minds, right, we're used to URLs. but it's a sort of slightly more general term for naming a resource, because obviously they're trying to express RESTful in a way that's independent of the particular implementation of RESTful with URLs and HTTP and so on, because it's a more general architectural style that, you know, you could implement, you know, using Java or whatever, right, and sockets or something like that, yeah. And if you did it using that, then you might use universal resource identifiers rather than rather than URLs. So the correct sort of general term is URIs for identifying resources. Now, resources are things, not actions. So we're accessing a thing through the RESTful API, and we're doing things to that thing. Yeah, if that makes sense. We're changing that thing, we're accessing the state of the thing, and so on. But what we're accessing, the resource, is a thing. So a resource could be a document, an image, a service, collection of other resources, and so on and so forth. And these can be entities that change, you know, or actually just static entities that, you know, don't change over time. So some examples, we have data about an individual thing, a person, so on. So names, address, grades of a particular student, that's a resource. Resource could also be a collection of data about things, persons, etc. So the names, addresses, grades of all the students in a class, that's also a resource. Could also be a sort of service. So, you know, you can have like a printer, again, that's a thing, right, which has a status, number of pending jobs, etc. The weather is kind of a thing, which has a wind speed, precipitation, so on and so forth. So the resources are sort of stuff, sort of things that are out there that we're getting the state of through our RESTful API. So we have so this is the universal resource identifier, and this is a string of characters that unambiguously identifies a resource. So if we weren't using HTTP and web stuff, you know, we could create our own way of identifying resources. And if you get into, you know, peer-to-peer networks and all this kind of stuff, you know, they're working, you know, in a different way. They're sort of got a, what's it called, overlay network, right? So we've got a sort of a network superimposed on top of the internet, and within that network, each thing will have its own sort of very, you know, special way of being named, its own uniform resource identifier. So that's why it's better to think in terms of a uniform resource identifier, because then we can generalize that idea to, you know, peer-to-peer networks as well as to the World Wide Web. So uniform resource identifier is a string of characters that unambiguously identifies a resource, and you can have multiple URIs pointing to the same resource. So as I said, REST APIs typically use HTTP. So URIs, if we're using HTTP, then URIs become URLs, right? A uniform. So we're going to create URLs that enable us to access the resource and get the state of that resource. So these are some general guidelines. So you're going to build your own REST API as part of this coursework 1. So have a little think about these guidelines, yeah? And I'll give you some links. There's a very good REST API tutorial online where, you know, quite a bit of stuff is drawn from, and I'll give you a link to that, because you need to think carefully about how you name the resources. Just like you've got Java naming conventions, you've got SQL naming conventions, and you've also got, you know, REST API naming or guidelines for naming resources in a REST API. So don't get hypnotized by what's in your database. That's really important, yeah? What you're trying to do is provide something that's easy and convenient for clients to use, yeah? You want to make it simple for people so people don't get confused. They don't have to work their way through all the documentation, and so that more people use the resource, because generally on the web it's very competitive. And if you've got your weather API, you want them to use your weather API rather than someone else's weather API, for example. So don't just look at your database and try and expose everything in that database, okay? Think about what the clients need and tailor your RESTful API to what your clients need. Or if you're designing for yourself, think about what your other applications running sort of separately on your system actually need, not about the data that actually happens to be there, yeah? So you might have to pull together data in different ways or process it a little bit to make it, you know, accessible to the client in the most useful way. Now, resource names should be nouns, not verbs, yeah? So you're accessing a thing, remember? So the resource name should be a noun. And then the HTTP is used to specify the verb portion of the request. So you're doing something to a thing, and that thing will be called, you know, should be named with a noun, yeah? So, you know, so plurals, so third bit of advice here is use plurals. So customers, not customer. Can't remember what it recommends with SQL, but it's probably the same. So that means your resource names can be consistent across all methods. So if you've got this is like a URI slash, that's a URL, right? But we've got apiexample.com, customers, that would get us all the customers, right? And then we can use put to customers /44, right? So it's better to have a plural here because then we can, it makes sense to say get to that plural name, and then the customers sort of like a collection of customers, isn't it? And then if we have /44, we're actually inserting a new customer with the ID 44 or updating that customer. There's no need to use words like list or vector to name groups of resources because that's, again, that's the layered constraint, right? That's the sort of implementation detail we just don't care about. So we can just use customers. We don't need to have customer list or something silly like that. Yeah, we're accessing all of the customers, and this is where we're talking about designing for clients, not for data, because there are behind the scenes, our resource could just be, you know, a vector sitting in memory on some server, right? But the customer, the client, doesn't need to know that. Yeah, they just know that they're accessing all of the customers and they don't care how that's stored. Yeah. So when we're using URLs, it's sensible to use the path to specify the resource that you want to access. So here we've got, you know, here's the path, that's our domain, right? And then this is the sort of the path that matters for our REST API, which is like customers or customers /44. That's accessing, that's specifying the resource. And then you've got the query string. Now that's it's still useful in a REST API, but we're not using it for naming the resource. We're going to be using that for filtering the resource, yeah? So we might have, you know, HTTP customers /4. That's our sort of URI for customer with the ID of 4. Don't do it this way. HTTP customers $ID equals 4. Some websites do it this way. It's not a very good way to do it because that's not really, we're not using the path to name the resource, and it's better to use the path to name the resource, and then use the query string here to. It includes some extra parameters like sorting or ordering, or you know, you might want just like the first 20 records or something like that, as I'll explain a little bit later. But if we use the path, then we can use the hierarchical nature of the URLs to suggest structure. So that's what we're doing here, right? We've got the customer with ID 4, which is inside the collection of customers. So this is a hierarchical thing. This is a sort of you know, this is contained within this, and we're using the path to actually indicate that same structure, which means people can intuitively understand your REST API better. Yeah. Always use your lowercase for anything web related. Heaven knows what browsers or HTTP you're going to do with capitalization. Just stick to lowercase, obviously, and use underscores or hyphens. Again, last thing you want is like all that sort of %20 thing, whatever it is, all those escape characters. Always, you know, never include spaces in any URIs, URLs, etc. Yeah. And keep your URLs as short as possible, right? You don't want your client having to type, you know, 100 characters in order to access a particular resource. You know, it should be nice and clean, and it's very unlikely, unless you're dealing with a, you know, it's very unlikely you're going to have to go for, you know, enormous URIs. So that's our resources, which I've explained, you know, given some rough guidelines how we should name them. Now let's look at the methods we use to access the state of the resources. So we got get, standard HTTP, should be super familiar to you. So within a RESTful context, we use get to read a resource, yeah? And it shouldn't change the resource. We just send a get to the REST API, and we'll get back the resource that we've requested the state of. Let me use then put. It's sort of defined as being used to update a resource, yeah? But sometimes, and there's a bit of an ambiguity between put and post, and really there's no, as I said, this is a set of constraints. It's not a prescriptive standard. So, you know, if you use put for one thing and post for another, that's okay as long as you use it in a consistent way. So put's sort of generally used to update a resource, but it can also be used to update to create a new resource if the resource identifier is known beforehand. So if we send put to a particular ID that we knew was a valid new ID for a particular resource, then we could send a put request to that instead of a post. So delete's kind of obvious, delete specific resource. And then we've got post. So post is usually used to create a new resource, whereas put's used to update a resource. But and again, we could post to a particular ID if we knew that that was the next ID in sequence, so to speak, not one that existed already. Or we could just do a post to customers, and then the ID could be allocated automatically. And sometimes post is used for other operations, because sort of sending stuff, we could use it if there's some funny operation that we can't fit into one of the other categories, then we can use post for it. So again, it's about sticking to the general guidelines, sensible use of the HTTP methods, but within that, you may find that you have to design some bit that doesn't quite fit into the sort of, typical REST approach, and then you can use sort of post to fudge it a bit, right? That's kind of what that's there for. Now again, HTTP has all these wonderful response codes, and most of these we can use as part of our REST API. Yeah, so it's standard sort of stuff, right? So we want to give the client feedback about the request that they've sent. Sometimes they're going to send stuff that's not working or invalid. They're going to request a resource that doesn't exist, and so on and so forth. So we need to give them feedback about that so they know what the error is, and give them feedback that's as specific as possible. So the classic one is 200 OK, right, which means that everything went well, they've got what they wanted, the request was all good. We might have a 201 created, which is like successful creation of resource via post or put, or no content, so that's successful but nothing's being sent back. If we posted something and there's nothing else to do, or delete, for example, because if you delete it, what's to say, right? We've got bad request or unauthorized. So under some circumstances, maybe if we, for example, if we did a put and specified an ID that already, if we did post to create a new resource and specified an ID that was already in the database, then that would be an invalid request, because if we were using post to create a new resource, then that's actually overwriting or updating a resource, so that would be like a bad request, yeah. Unauthorized, so if we'd had some kind of login functionality and we're missing like the authentication token, then that would be an unauthorized. And forbidden, I don't know, let's not go too much into this. If we send a GET request to an invalid URI, we might get a not found sent back. Method not allowed if we send a you can imagine examples, right? The one that I happen to have used in my example is 500 internal server error. So you should only return this when something's gone wrong with the server, but not something gone wrong with the client, because this tells the client nothing, yeah? So if the server creates an exception because of bad programming or, whatever, something crashes, whatever, you should send back an internal server error. But obviously do your best to provide meaningful feedback when the client's making a mistake. Yeah, you want to tell the client if they've made a mistake, but if they haven't made a mistake and you've just done something wrong, then maybe you could pass back an internal server error. So this REST API tutorial.com is a very nice resource for explaining all the different bits of REST API, has a link to Fielding's thesis. So I recommend having a little look at this, and this also goes into all these tips kind of taken from that tutorial. So when we're accessing the resource, HTTP is all about getting a bit of data from somewhere, often HTML, right? But in the case of a REST API, we're returning data in the body of the HTTP response. Used to be, that everyone loved XML, but it's not very compact, and it's quite complicated to parse. So most modern web services use JSON, which is a lot better for this kind of thing. So later in this lecture, so that's my introduction about the constraints of how to build a REST, of the sort of the thinking and the architectural stuff, and the how REST APIs kind of work at a sort of fairly high level conceptual description, of how REST APIs work. That's what I've given you so far, yeah. So later I'm going to show you actually how to build one using Node.js, but first I want to go into a couple of topics that are sort of preconditions for building a better REST API with Node.js. So I didn't have time in last year to go much into any of the detail of this, so I didn't cover connection pools with Node.js, which is very useful to know and understand. And I didn't go into callbacks either. So I'm going to explain these two topics first, then I'll explain my design for my pretty mediocre REST API, and I'll explain my implementation of that, just so you've got a guide about how you can actually go about building these things. Okay, so connection pools. So in the CST 2550 lecture on Node.js and MySQL, I showed you how to create a database connection, select data from the database. And a lot of you use this code and it kind of works, but there's there's a couple of flaws in it which I didn't like, and one of these is the connection pool thing. Because what I did in this example, I used a single connection to handle multiple HTTP requests. So what I did was, got the MySQL module up, we created this connection, connected it, then we probably did some stuff with it, and then in the end we closed the connection. So this is fine if we just got a simple example running on a, running locally on a machine, and then we just got a single local host connecting to it, and it's using this connection to do some stuff with the database. So this connection here might be used to add data. For example, we do con.query, query, and it does something or other and replies back to the user. And then, in our local browser, we type in something else and it does something else, and that works fine. But it's not very scalable, right? Because we just got this one connection, and if we had 2 requests coming at the same time, it'd probably just crash, yeah? So if we're using connections in this way, or connections in general, are designed for a single thread, yeah? You open up a connection within a single thread, we can't actually share them between threads. Whereas a real web server, right, it's going to, if it's popular, we might get hundreds, thousands of requests every second, yeah? And the web server somehow, got to handle that using a finite number of connections. So we obviously need to do our best to provide multiple parallel connections to the database. We can't, can't deal with the first request and the second one and the third one, and so on and so forth. It's going to take forever, particularly since it takes time for each request to be executed. It's also slow to open and close a connection for each HTTP request. Well, that's true, but it's also slow to open and close a connection to the database. Right, we don't want to open this. A slight mistake there, I think. So if each HTTP request that we receive opens a new connection to the database, well, firstly, we're going to run out of connections very quickly, but also this is kind of slow, yeah? And the reason it's not going to work anyway is because databases have a limited number of potential connections, maybe 100, 200, whatever. Maybe some kind of high performance server would have like 1,000, I've no idea. But there's a finite number of connections to any particular database. And so if you exceed that, it'll just block you and you won't be able to get any more connections. So the solution to this is to use a connection pool. So we create a pool of connections, which are all sort of up and running, so to speak. And then when we have an HTTP request come in, we provide the code that services that request with a connection from the pool. You can use that to search databases or whatever. And then it returns that connection to the pool after it's been used. So we don't have to keep opening and closing connections to the database. We can reuse the connections in response to the incoming HTTP requests. And we can then set the size of the connection pool to match the capabilities of the relational database management system. So when you set up MySQL properly or whatever, there are parameters in it that let you set how big the connection pool is, and there'll be some kind of trade-off with kind of memory and performance and all the rest of it. So you'll set that pool to a certain value, and then you can actually set you can set up your RDBMS to handle a sort of maximum number of requests, and then you can set up your connection pool so it doesn't exceed that maximum. That's the idea. And this is going to help us with the performance and scalability of our application. Very easy to create a connection pool. It's no harder than doing this other connection stuff. All we do is, get the MySQL module, and then we just ask it to create a pool. And here we have like the connection limit. This is how many connections. So obviously we might set that to 50 or something if we're on a proper web server. And then as usual, we set the user, password, and database and all that kind of stuff. Yeah. So very, very easy to create a connection pool. And then to use it, it sort of works the same way. Yeah, we just have connection pool.query. And in this case, we're passing in a bit of SQL to the connection pool. It will use one of the connections in the pool to execute the query that we're passing in this case, this select count from serials or whatever. And then it'll call this function at the end of it, function blah, 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 blah. This is the callback function. It'll be executed when it's run that query. And it'll pass in the error and the result to this callback function. And then it'll be executed and do whatever it needs to do. So it's very easy using connection pools, and I recommend that you move from the sort of very simple connection-based approach to the connection pool approach when in your coursework one for this term. Yeah. So the other thing I wanted to cover, which was actually confusing for me last year and confusing for a number of you, is this issue of callbacks in Node.js particularly, but it's actually kind of a general JavaScript thing. So Node.js uses this asynchronous programming model. So it's a bit like the threads, right? We talked about this lecture on threads. So in lecture on threads, you can either have everything running within a single thread and one thing comes, nice and simply after another thing. That's a sort of synchronous programming model. But with an asynchronous programming model, you have like multiple things going on in parallel, and there's no sort of fixed time order between the sort of bits of code running in the different threads. Yeah. So the functions are called at different times, just depends how long they take to execute and how busy the CPU is and so on and so forth. You can't predict, whether one thing's going to come before another when you're running multiple threads in parallel. And so callbacks typically used within Node.js when you've got sort of something that's going to take a bit of time, yeah? And then in that case, you pass in this sort of a function that's going to be executed when the asynchronous functions finish its work. So this is not a super clear way of saying it. Let's rephrase it. Yeah, so we've got an operation that takes a bit of time, and we don't want to just sit around waiting for that operation to take time because we want to get on with other stuff. We want to be a super efficient server. So instead of waiting for that function to complete its task, we pass it in another function, and when that first function finishes, it calls the second function that we passed in and does whatever has to be done at the end of that function. So it'll become clearer with an example. So what happens is we're calling a function, do some work. We want to get some stuff done, right? This do some work function doesn't return a result. Instead, we create another function, work completed, and we pass that as an argument to do some work. So if you're not clear on treating functions as variables, or the fact that functions are variables in JavaScript, there's a lecture on advanced JavaScript in CST 2550, which you can just look up on YouTube, which explain this. Because if this kind of way of expressing things is confusing for you, you need to go back and get clear on what functions are in JavaScript. But I'll assume that you're clear on that for this lecture. So we've got a function, do some work, and we've got another function, work completed. We want this is going to be called when this function completes, yeah? So we pass this function as an argument into this function. So we call do some work, we pass in this function, work completed, and do some work will call this function when it's finished. And this work completed is the callback function. So it's calling back to say that the work's all done, yeah? And these functions are often anonymous, yeah? So you often just see this, I'll give you a couple of examples with a non-anonymous one, an anonymous one, just try and make it all super clear, yeah? Okay, so here, in this little example, we've got this function work completed, okay? And that's the result from the work, yeah? And then all it's doing is logging out the result. And here, we've got the actual function that does some work, okay? So we've got do some work, and all it's doing is adding up a bunch of numbers. And then when it's finished doing this heavy bit of work, it will call this function here. So I think I've got it here. Yeah, right. So we're passing in the callback function. When it's finished adding up the numbers, it calls this function just by appending these smooth braces to it and passes in the result from that piece of work that it's just done, yeah? So it'll do the work and it'll call the function that was passed in as an argument. And so that's what we're doing. We're calling do some work here, passing in this function as an argument, and then this function itself will just output work is completed, yeah? So that's a named and sort of, named, I'm not sure what the opposite of anonymous is, but anyway, a named callback function because we've got a separate function, work completed, that's passed in to do some work. But the way it's more commonly expressed is in this way. So we call do some work, and then we have an anonymous function here. So when it's completed, the callback function here, I think I've got it highlighted. So this callback function here is in this case, this anonymous function here. Yeah. So this is, kind of variable function thing. This is what's passed in here. Yep, that's right, because we're calling it. And then that's what's called here as well. So this is calling this anonymous function here. So let's just quickly show you, because it maybe help when we come to explain when we come to the more advanced stuff. So here we've got to do some work. Let me just stop this server running. Okay, so this is exactly what I showed you. This is the one where it's named. So so all this is doing is calling do some work and passing in this function here. And then this callback function, this will then call this function here, passing in the sum that's been added up here. I hope that's clear. We can go into it in more detail in the Q&A session. So I'm going to run this. So it sits there for a bit, right? After it's done all this summing, it comes with a rather bizarre result, which I don't understand. And anyway, but it's working. Yeah, it's calling the callback function with a sum here, and it's passing that into here and logging it out. Yeah. Don't ask me why that's that enormous number. Yeah, I mean there'll be something funny going on with overflow or something, I suspect. Okay. So this is a synchronous example. So there's nothing multi-threaded about the examples I just showed you just now. It starts to get confusing when we get functionalities implemented in separate threads. So if we're accessing a file or database access or something, what Node.js will do is it'll put that the functionality in a separate thread, and then the callback will be called from that separate thread. And so we need to handle this a bit more carefully, because otherwise we're going to get problems with the ordering of events. And that's when things start to get a little bit confusing. And that's what confused me last year when I was explaining all this SQL stuff. But it's all clear now, and that's what I'm explaining, yeah? So we have an asynchronous callback example here. So in this case, what we're going to do is just use a file, something that reads from a file, which is executed in a separate thread in Node.js. So we're going to use the file fs module, which just enables us to read from files. And then what we're going to do is we're going to do fs.readFile. This is sort of built-in method of the file system module. We want to read this file, and when this file is finished, we're going to call file read is finished. We're going to call file read complete. And so file read complete is a function, 2 arguments. That's what's defined with read file here. It's got errors if there are any errors, and it's got the result from reading the file, which is the contents of the file. So when this finishes, it's going to call this callback function, and we'll see callback function file read is completed. Yeah. So let's run. So if we run this, what we see is this: we see about to read file, so it logs it out. So if this was an asynchronous program, what we would expect to see is it would be about to read the file, it would read the file, and then it would log file read is complete. That's what we'd expect to see in a sort of standard program. That's a standard single thread, and we get 1, 2, 3. That's what we'd expect. But what we actually see when we run the program, we see about to read file here, we see file read is complete here, and then we get the callback function here, which makes sense, right? Because this is a separate thread. This takes some time to do, and so this is only going to be executed when everything's done. Whereas the main thread of the application is just going to do that, start the thread, and then finish saying file read is complete. So what we actually see in terms of the sequence of events is we see about to read file, then we see the file read is complete, and then we see then the callback function finishes and gives us this log message out here. Yeah, and that's when it can get a little bit confusing when you're dealing with this for the first time. So let's just do a little asynchronous one, just for fun, I suppose. So here's my callback file example, exactly what I showed you. Let's just run that. So we've got about to read file, that's this bit of code here. Then file read is complete, that's this bit of code here. And then we've got the callback function here. And the reason this comes after this is because it's calling this in a separate thread. This has been called in a separate thread after the separate thread has done its work. So in a way, what's actually doing this is outputting that, launching the separate thread, logging that out, and then when the separate thread finishes, then we get the message from the separate thread saying that this has happened. So the same is true of MySQL, right? Database functions are typically asynchronous. So callback function is executed when the data has been retrieved. So it's exactly the same as I showed you with this little file example. That your main thread will just keep going, keep going, keep going. It'll launch up a separate thread that'll go off and do database stuff. And when that separate thread's finished, it'll then call back and call the function that you've specified should be executed when the data is retrieved. So obviously you don't want to sort out the HTTP response within the main thread, because that main thread doesn't have access to the data. That main thread's just going to keep going. And if you send off the HTTP response in the main thread, then that's going to reply before the data has actually been retrieved. So you actually should handle the HTTP response within the callback function that will be called by the database thread. When I'm calling these threads, I mean, there may be virtual threads or an actual, we'll call them threads for simplicity, but the actual implementation details I'm not aware of. But within the separate, so you need to, the separate thread that handles the database stuff will call the callback function. So it's that separate thread also has to handle the HTTP response. So here's my little examples that you see. So we're calling a query here, we're querying the database, and this chunk of code here is a separate function, and that separate function will be called when that SQL has been executed in the database, and we've actually got either an error message or the result from executing that SQL. And that's all going to happen within a separate thread. That's our callback function here. Within that callback function, we can then do the processing of the response. We can set if there's an error in the message, we can then set the status of the response. And obviously we need to make sure the response is somehow globally accessible to this thing. So if it's not if we can't access the response within this function, we need to fix it so we can. So here you have the, then we can, if we have an error, we can set the response to the status appropriately and pass back an error message maybe. Or if the response is, if everything's fine, then we can actually put the data into the response and send it back. The important point I'm making here is that the response has to be handled within the function, within the callback function that's passed to the query. So I don't recommend that you modify the response out of the callback function. You can modify it before, you can add some bits to it initially before the callback function, but the callback function as well should kind of complete the response and send it back, yeah, because it's running in a separate thread. Otherwise, if you're trying to modify the response in your main thread and in the separate database thread, you know, you've got this kind of classic synchronization problem. You've got two threads that are accessing the same thing simultaneously, and it could end up in an inconsistent state, and that's certainly what I found when I was playing around with this stuff. Now, you might have a situation where you need to make two calls to the database, okay? And that's going to get tricky, right? Because we can't handle the response within the main thread or build it up by calls to the main thread because we've got this threading problem. So in this case, we have to use nested callback functions. So we make call one, so we do one database request with a callback function, and that callback function itself makes a separate another database request with its own callback function, and it's like the callback function within the callback function is the one that actually handles the response and sends it back. So it can get a little tricky, and I'm going to mention this kind of callback hell issue and a couple of tips that might help with that. Here we go, right. So in this sort of little hypothetical example, which I'll actually explain in the final section, we've got like one callback with another callback, and it's the second callback, the second nested callback that actually does the response. All of this can be a bit confusing, right? So this is like a website called Callback Hell. You know, clearly it's not, you're not alone if you're finding all this confusing. So here are some recommendations to reduce problems. So some people can be super enthusiastic about this. Maybe they've done a lot of functional programming and they've got like 20 callbacks all nested within each other, and they think it's super clever, but actually it's just super confusing. Yeah. So keep your code shallow. Yeah. Make it super clear, you know, what's calling what as much as you can. Yeah. So you can do all this anonymous functions. So you can have functions within functions within functions. They're all anonymous. Again, you might think, oh, I'm saving myself typing 5 characters every time. Aren't I amazing? But that's actually not true. Yeah, it's better to be as clear as possible because your code is going to be more maintainable, yeah, and less confusing and easier to debug. So try and name the anonymous functions if you can. Give them names. Put them in separate parts of the code. Comment what's being called by what and all the rest of it. Yeah. And so this is a suggestion from Callback Hell about wrapping code in modules. So you can put things in modules. I'm not quite sure how that helps, but that's his recommendation. I'll have to look into more detail about how that might help because you've still got the threading issue. But anyway, I suppose if you wrap it in a module, then you only have from your perspective of using the module, you only have a single callback, I suppose, even if there are 5 callbacks nested within each other within the module. Maybe that's probably how it's actually going to help you with this. And obviously you need to handle every single error. The more fine-grained error handling that you have, the easier it's going to be to figure out which of the nested callbacks is actually generating the error. This website here I took these tips from. You can have a little bit of a look at that. Yeah, it might be useful. Another way people try and address this problem is through promises. So this is, I think it's been added to latest version, certainly in Node now, but whether it's in client-side stuff, I don't know. We can use promises to sequence asynchronous operations in a particular order. So it's a little bit of a fudge. It's a way of sort of converting multi-threaded stuff sort of into single-threaded stuff. That's why it's likely to reduce scalability and performance. So, you know, it can make things conceptually easier using promises, and some modules in Node use promises, but I wouldn't necessarily say it was, you know, it's better to get clear on how callbacks work and use callbacks properly, I think, than to mess around using promises to kind of make it easier for you to think through your code, yeah? So use them when they're essential, obviously, but don't just use them to make it easier to write your code because there will be this kind of scalability performance impact from them. So I'm not going to bother with an example, but I'll just show you how they work. So the idea behind a promise, again, you have to just look it up if you want to figure out the full details, because it's just not time in this lecture. We're already on slide 67, right? And I've got a couple of, you know, another 40 slides to go or something. So I'm not going to go into the full details. But the idea is we create a promise, which is a new promise, a particular kind of JavaScript class, right? And we pass into this promise resolve and reject. And the promise is something that we actually do, right? So here we have a function, yeah, that does something in this case, and it'll do this in an asynchronous way. So in this case, it's reading a file. The idea of a promise is that when we call resolve, and possibly even when we call reject, I haven't tested this, but when we call resolve, that's like saying that this particular action has been done, yeah? And so we do something that in an asynchronous way, and when that thing has been done, we call resolve, and then that says to, Node, execution environment, whatever, that this particular act has been done. And then we can chain the promises together. We can say file promise, once this promise has been completed, and then we can do something else, yeah? So in this case, file read is complete will come after this console logging here. Whereas if we did it, if we didn't have the promise, we'd get this happening first and then this. So, but because we're using the promise structure, we're saying then, after the promise has been resolved or rejected, this will then be executed. And then we could chain promises together in a way and get a determinate sequence of events from asynchronously executing code. That's the idea. So we call resolve, and after the resolve, we can then, the then will then be executed, yeah? So if we look at this, here we're getting about to read file, then we're getting the callback function, and then we're getting file read is complete. So we can sequence things that are running asynchronously in a determined order using promises, but as I said, I think it's better to get clearer on how the callbacks work and only use promises when you really have to, or because they're part of the library. I think I was using, I think there's that, can't remember the name of it now. In the next lecture anyway, I'm using a little library to do my HTTP requests, and I think that's based on promises from what I remember. Okay, so that's a couple of things, a couple of tricky things in Node that you need to be aware of to be able to write better code. Now I'm going to give you an example of a REST API, and this section is just going to be the design of the REST API, which you should obviously do first, and then I'll show you, quickly how you can actually implement that API using Node. So the first step is, with any REST API, is think carefully about the design. Remember, you're designing for the client, not for your data. You need to use nouns, all that stuff. Think about how you're going to name your, manage your URIs and so on and so forth. So there's a whole design stage to any REST API. And obviously in your final report, I want to see a design of your REST API. I think I even put that in the marking criteria. So this design process, we need to think about what we want to do when we send get, post, put, and delete to different URIs. So we've got an idea about what we actually want to implement. So obviously it's sensible to write it down before you implement it. So you've got a very clear idea, and that's what I'm trying to show you in this section. So what I'm going to give you now is a simple example of a REST API designed for my serials database. I'm not just going to expose the serials table because there's a layer constraint. I don't have to do that, right? I'm trying to design for the customers, not for the data. And if you remember, if you look quickly, my serials table is actually really, there's at least 3 fields in there that are just foreign keys, right? So that's not very useful passing the customer back like product type ID, because then they've got to make a separate call to the product. If I've got a product, my product's exposed, in a different way, on a different URI. It's not easy for the customer. Yeah, I'm not going to just expose the serials table. I want a serials REST API that enables the customers or clients, to access the serials. Yeah, that's a sensible design. So instead of just exposing the serials data, I'm going to use inner join to combine the data from different tables and provide more useful results from the client. That's what this is. So here's my example database. So obviously I've got my serials table, which I'm not going to just expose by itself. Instead, I'm going to use join to link all this data together so that I can return like the name and the description of the product, as well as the brand and so on and so forth. Yeah. So this is design, and this is a sort of sample of the sort of thing that I want to actually return. I mean, this is actually generated from my implementation, right? But I'm just trying to explain it as an idea. Yeah. So my design, these 2 points are what I really need. Yeah. I want to say that when I send a GET request to this URI, serials, which is like a collection of serials, right? It's going to return data about all serials in JSON format. If I send get to my API serial/2, it's going to return the data about the serial that has the ID equal to 2, and it's going to return it in JSON format. If I send get to serials, and then with this, that's like all the serials, right? But with the query string number, you just about see the underscore there, number items equals 3, and offset equals 3. That's saying I want to return 3 items from my serials, 3 serials, starting with the third serial, I think, something like that, or third or fourth serial. I always get confused with that. So it's going to return, that's actually, sorry, that's incorrect. It's not data about all serials in Jada format. Well, it is getting data about all serials, but then it's filtering that by limiting the number of items and the offset on those number of items, yeah? That's what we're doing with a query string. So we can do pagination, right? If I've got like 1 million serials in my database, obviously I don't want to return them all at once, yeah? So that's get, then post. So if I send a post request to serials, it's going to create a new serial with an automatically generated ID. And the data for this serial is going to be in the body of the message. And if I send post here to serials with /8, somehow I'm going to have to know that 8 does not exist in the database. So we're not going to use this very much probably. But in this case, it's going to create a new serial with ID equals 8 or return an error message if this already exists in the database. And then put, we kind of use this to update my serials. So it's going to update if I send a put to this URI, it's going to update the serial with the ID equals 8 and the data for the new serials in the body of the message. And I could use put to create a new serial with ID equals 8. I would probably not include this in my REST API if I sort of thought about it. I prefer to have a separate method for creating stuff, but you know, potentially it wouldn't be incorrect if I wanted to use put to create a new serial with ID 8 here. Okay. And then delete's easy, right? If I want to delete a serial with a particular ID, then I send a delete message to serial /8. And if I want to delete all the serials, you might want to, you know, be a little careful with this, how your REST API handles this. But yeah, that's you know, the sensible way of deleting all serials. Send a delete message to all serials. Yeah. Okay, so that's my design. Yeah, I've sort of shown you, and I've shown you the sort of data and the responses might get from that. In fact, what I would probably add to this design if I was doing it properly, which obviously I'm not, it's just a little example, I'd probably add the HTTP status codes that would be returned under different conditions, right? If this was a proper design that I was doing for a company, I'd put all the HTTP status codes that would be sent back under different conditions and the formatting of the data and the messages and so on and so forth, yeah? Not going to do that here, but, you know, obviously a proper REST API design would, you know, take, you know, 20 pages or something like that, yeah? So now I'm going to very briefly explain how we can actually implement this REST API using Node.js. Just some key points. I'll put the example code online, and you know, you're welcome to adapt and use it if you want to. Obviously your data is going to be different and your URIs are going to be different, so on and so forth. I'm presupposing you're familiar with the basics of Node.js, Express, MySQL. All of this was covered in these lectures, right? So the introduction to Node's all there, Node.js and MySQL. You can just go back and watch these lectures again. If you've forgotten this stuff, and I don't blame you if you have forgotten it, because it was like, you know, April last year. It's a long time. So you might want to watch this stuff first if you're struggling with what I'm introducing in this lecture. So obviously, the beginning of all this, when we're building our web service application, we need to do the basic stuff of importing modules. In this case, I've created a file defining the HTTP status codes. No doubt there's a Node module that has that already, but I couldn't be bothered to find it, so I just created a little file with the HTTP status codes. I'm going to be using connection pools, as I explained earlier in the lecture. And this is just an implementation of the get part of my REST API, okay? And that's all I'm expecting you to implement as well. I'm not expecting you to implement post or put or delete or anything like that, because you're putting all the data in the database using Java and Hibernate, so there's no need to implement, you know, all the post and put and stuff, you know, on top of that. Yeah, I mean, of course, you could, instead of using Hibernate, we could have used our REST API to put the data in the database, but you know, I'm trying to teach you a mixture of technologies, so that's why we've done it that way. So we map the guest request on particular paths, which you should know from the previous lecture, and then we just start listening. So I just created a little JavaScript object with all the status codes. As I said, this probably exists in Express already, but never mind, I just made it easy for myself. And then we set up the app. I'm not going to go into the details of this because this was covered in the lecture on Node. Yeah, so but just to, you know, we could access the various modules we need. I'm using to pull in this file here, which is defined in HTTP status.js. Then we're using Express, MySQL, creating the connection pool, and then we're mapping particular paths onto this function that handles the GET requests. Yeah, and then we just start listening on 8080. So first thing we've got to do in our app is handle path and query string, right? We're getting an HTTP GET request sent to a particular path with a particular path and query string, and then we need to identify the path, read the query string, and then we can call the appropriate database functions to carry out the appropriate actions according to our REST API specification, right? So the path and query string stuff, again, this should be well within your competence, right, of being able to pass the URL, extracting the queries. So this URL module I'm using here, has all the built-in functionality for extracting the queries and extracting the, so we can get the queries and also get the path out the URL object. We do some very basic JavaScript processing to get out the number of items and the offset. So I think I'll cover that in the next I'll cover that in a little bit. But what these are doing is I'm specifying how many items I want to return, the maximum number of items I want to return, and the offset. So I can get using these two query string parameters, I can get the first 20 items, the next 20 items, and so on and so forth. And obviously that depends on knowing the total number of items, which I'll kind of explain. So we're getting the end of the path, we're getting number of items offset, and that's kind of what we need in order to call out database functions. So this is, bunch of processing of the path in order to call the correct function that I need to. So if the path ends with serials, then I want to return all of my serials, right? So I'm calling get total serials count. I'll explain these methods in a second. Key thing is here I'm passing in the response the number of items in the offset, so that my callback function within get total serials count can actually finish off the response and send it back to the client. And obviously, in order to do the full response, I need the number of items in the offset. And this is like sort of same kind of thing. I don't know if I did. I thought it was confusing with having lots of like and statements and so on and so forth. So I just did the same thing here. It's just if it ends in a slightly different way, we end up in the same way. And then this final bit is I've got a regex that's checking for the ID. So if a path ends with the ID, then I just want to get a single individual serial here. So again, I'm passing in the response and I'm passing in the ID of that serial so that I can then return it to the user. So this is all done with pagination. I'm expecting you to do pagination in your projects. So with a large data set, obviously we don't want to send all the data back to the client at once. So if we've got 1 million rows in our database, that's going to take an awful long time to send over the network. And not only that, if you've got 1 million rows in your browser, it's going to really struggle to fish out the bit that it actually needs, and there's no way it's going to display them all to the client. Anyway, right? So far too much network stuff, far too much client-side processing, and it's a waste of time for everyone. So with any kind of big data stuff, we need to specify how much data should be returned back to the client. And in my REST API, this is done with 2 query string parameters. I'm not saying it's the best way of doing it, but it's one way of doing it. And it maps nicely onto the database stuff. So I can specify the number of items and the offset. So I should have some default way of specifying what number of items is, which I haven't got. So in fact, my REST API, if you didn't specify this stuff, this implementation would just send back everything, which is bad. So I should fix this, but it's just an example. So I've got the number of items, which is maximum number of items to return, and the offset, which is the starting point for selecting items from the database. To make pagination work, obviously the client needs to know the total number of serials. So if you look on any website that has a lot of stuff, you typically get, like in the bottom corner or whatever, when you've got a large results set, you'll have like page 1 of 7, page 1 of 27 or whatever, and then the client can click on that to select the next page of results. But to make that work, to handle pagination correctly, the client needs to know how many serials there are. Now, I did have a quick fiddle, but I couldn't figure out a super clever way of writing a single SQL query that retrieves some of the data and the total number of serials without a count value on every row. So you can, I think I figured out how to select count on a data set returned that had count on every row, but that's kind of a bit crude and not great. So I decided in the end to make 2 separate calls to the database, and obviously that's got a performance hit. But on the other hand, on the good side, it does let me show you how you can do nested callback functions. So I'm going to make 2 separate calls to the database. As I said, there's probably some way of getting rid of that, and you probably have to do some performance measurements to decide whether it's better to have count on every row or better to make 2 separate calls. But set that all aside. Under some circumstances, you might need to make 2 separate calls to the database in order to return the data that is appropriate for the client. So my first call, I'm retrieving the total number of serials, and the second call, I'm retrieving the specified number of serials with an offset. And this enables me to return the specified number of serials and also the total included in the result. So my first thing, and that's why here I'm calling get total serials count, because I'm going to get the total number of serials. That's this method here. function here. So I just select count from serials. So that's easy, cheap, quick thing I've got to execute on the database. So I run that query and call this callback function. And let's just see where we get. Yeah, so standard callback function, right? So there's no pagination or anything here. So let's just go for that. So obviously it's an error. We handle that with the response here. I'm getting the total number of items from the result, which has this sort of field value count with the star. And then, once I've got the total number of items, I then make a second call to a function. And that separate function, this is within the callback function, so within the thread of the callback function, I'm then calling get all serials. I'm passing in the response, I'm passing in the total number of items that I've just fished out of here, and I'm passing in the number of items, and I'm passing in the offset. So this is my second function that will then be called within the callback function. That has this sort of complicated bit of SQL, and if I need to, I can use, if this is specified, then I can add on order by serials. So I've got an ordered result, because otherwise, you know, it's going to be a bit of a mess. If you're doing this filtering, you also need some kind of ordering, and then you can use limit and offset. These are sort of SQL stuff you can use to limit the number of items and provide an offset. So it's very easy if you're using limit and offset. If you know, SQL makes it very easy to select a fixed number of items with an offset. Then I run the query. Then the query will give me a certain number of serials, and then I add into this object I'm going to return another field, total number of items, which I've already got passed in from the previous callback. When I call this callback function, I passed in total number of items. So I'm putting in both the total number of items and the data, and then I call response. So this, and all of this is happening, let's just see, now I don't specify it here, but all of this is happening in here, right, which is the callback function from the SQL, from the database, yeah, from the database interaction. So just to trace the series of events, because it can be confusing, so this is called by my main thread. This calls this callback function when it's complete. Within this callback function, I'm calling this. This itself has its own callback function, and that final second callback function is then returning the result with the response here, and it all works just fine. And then if you need to retrieve a serial with a specific ID, that's the method there, which is just doing, you know, selecting. This is still doing the inner join stuff, but then I'm actually saying where serials equals ID and doing the same thing, except without the second level nesting of the callback functions. So let's have a little demo. Show you it working in action, because, you know, it does work. So if we go to serials, there's my, right, I need to start it all running. Where's my server? There's my server. Okay, so this is my server. Let's run it, start it running. Okay, so, right, what do we got here? Why is that not working? Let's just check. True message now. Okay. So this was working beautifully, obviously, earlier. So the question is, am I running the right thing here? Which I am. If I rerun it, is it still going to give me the same error? Hey, okay. I don't think I need to switch on my Wi-Fi, but let's just check that. Oh, there we go. For some reason, it needs to be on the network for serial for the connection to work. Don't ask me why, because it's localhost. But anyway, never mind. So if we send a GET request to serials, like get all serials, then I get my total number of items 13, and then I get my data here that contains, you know, a sort of JSON object representing each of the serials in my database. If we send a HTTP request with the number of items 3 and offset 2, then it's going to return 3 serials, even though the total number is 13. It's giving me like 1, 2, 3 serials, right? And the offset is ID 4. So we've got 1, 2. So it's giving me the second item in that case. So if I do offset equals 5, right, it should give me starting at data starting at 9. Well, I'm not going to bother counting it, but you get the general idea. Yeah, and if we turn total number of items 5, you know, it'll return like more 5 items up to the maximum. Yeah. And if you want a specific ID of a serial, then that's I send it to the serial / the ID, and then we get the ID 60 and all the rest of it. Yeah. So this is the kind of API I expect you to build as part of Coursework 1. Now, I strongly recommend when you're building these kind of complex queries, if you look at this query, right, it's not trivial, yeah? You've got this inner joining, you've got limit and the offset and so on and so forth. SQL queries can get pretty hairy and pretty complex. It's a Trinity mirror, you know, the queries like, you know, like that, right? It wasn't so easy to understand what they were doing. And Node.js doesn't always give helpful errors when a query fails. Yeah, sometimes it does, sometimes it doesn't. So what I would do, if you're building a query that looks a bit like that, test it out and hide SQL or the command line or some other graphical tool, I don't care, but test it out and then put the query into code. If you know that that query works and you put it into your code, then the code might be failing, is likely to be failing for some other reason, not because of some SQL issue. Yeah. So test the queries first. Yeah. If you look at the select syntax, you can easily see that if you're starting to use some of the more, you know, advanced features of SQL, you know, there's a ton of stuff in there, and you need to test the queries out to make sure it's all working nicely. So there are 5 marks for a RESTful API in Coursework 1, possibly as well, top of my head, there's probably 1 or 2 marks for actually documenting it properly in the final report. So you can either build a RESTful API that is sort of vaguely intended, you know, if your website actually ever went live, for kind of like third-party developers, right? So there's lots of APIs out there, you know, RESTful APIs out there that other people use, sometimes for a fee, sometimes not. This would be the kind of idea of a separate service that enables third parties to directly access your data. So if you've got a sort of strong idea about how you want to build your website, then you don't have to build it around the idea of a RESTful API. Personally, I would definitely integrate your RESTful API into your front end via Ajax, because then you've got the data coming in a nice, easy format. It's easy to ping it and get different bits of data. And then this is by a long way the most sensible approach, but I'm not forcing you to use that approach. Yeah? And as you'll see in the lecture with Vue, it's so ridiculously simple to integrate a RESTful API with Vue that, you know, you'd be crazy not to. But anyway, that's your call. I'm only expecting you to implement get. You know, in case that's not clear, that's the bit that you need to implement in order to make your website function, because, as I said, we're using Java and Hibernate to put the data in, so you don't need to implement post, put, or delete or any of that. Okay, so that's the 5 marks. Here are the resources. So as usual, I put all the example code I've shown you in here. And this guy, yeah, Roy Fielding, right? He's the guy who came up with the the idea of a RESTful web service in his PhD thesis. So you might want to have a little look at that as well. And there are various tutorials. This is, I think this is the most useful one here. It's like a whole website dedicated to little examples and tutorials on RESTful stuff. Okay, so this lecture I've explained how you can design and implement REST APIs, and the next lecture is going to introduce Vue.js.